Welcome back, and we are going to solve problems about vectors in the plane. Vectors in the plane have only two components. They live in the plane, let's say xy. They have only two components, and these are the two problems that we want to solve. Let's go to solve the first one. These problems are based on the parallelogram rule that say that when you have a vector C, the vector C is made of two vectors, the A plus the V. A plus V gives C. So the vector equation that we will write is that the C is equal to A plus B. In some way, we can think of A like an operator that moves things from the tail to the head. V moves things from the tail of B to the head of B. And C moves things from the tail of C to the head of C. So what we are saying is that when A and B are acting, is equivalent to Z. Acting of C is equivalent to A plus B. What we are saying that if A and V are a displacement vector, if A displays 3 meters in the x direction and 2 meters in the y direction, and V displays 1 meter in the x direction and 3 meters in the y direction, C will displace how much in the x direction? The 3 and the 1. The C is here, C is here. The 3 and the 1. Well, this is 1 also. And he displays up 2 meters and 3 meters. So the operation of A plus B is equivalent to the operation of C. So C equal A plus B. And from this equation we can say that V is C minus A. What it means that B is the vector that goes from the head of A to the head of C. V is C minus A. B is the change in A. A plus V gives us C. So the V is the change, is C minus A. So what we will do to do problems in these lessons is to find, given P, the point P, x1, y1, the coordinate of the point P, x1, y1, and given Q, x2, y2, given P and Q, what is the vector that goes from P to Q? The vector that goes from P to Q is the vector OQ minus OP. So the vector PQ is the vector OQ minus OP. Why? Because this is C, this is A, this is V. V is C minus A. Okay, who is OQ? OQ is the vector that goes from the origin to the point Q. So it's x2 in the x direction, I, plus y2 in the j direction, y direction, going up. So if you move the vector OQ, if you move x2 units, let's say 5 units to the right, I means to the right, you move y2 units to up, y2 units up, you arrive to the point Q. To arrive to the point P, you need to move x1 units to the right, let's say 3, and maybe 1 unit up, 1 unit or y1 j, 1 unit up j. So the vector OQ minus the vector OP is x2i plus y2j minus x1i plus y1j. How we subtract vectors components by components? x2 minus x1 in the I direction, y2 minus y1, this minus y2 minus y1 in the j direction. So the vector PQ is always x2 minus x1, I plus y2 minus y1, j. And this is what we will use to solve problems. The first problem say the vector u has an initial point 3, 2. So the tail of the vector u is at 3, 2. What is 3, 2? 3 and 2. This is the tail of the vector. And the terminal point is 5, 6. This is the head of the vector. So the vector is this one. This is the vector. And the other vector, v, has an initial point 1, 4. This is the point 1, 4. And final point 3, 8. So this is the vector that goes from the head of the tail is this one. And the problem is asking, prove that these two vectors are equivalent. When two vectors are equivalent, they are equivalent when they have the same components. You see here, this vector is made of 2 units to the right, and from 2 to 6, there are 4 units to going up. So this is the vector that have 2 units here from 3 to 5 and 4 units from 2 to 8. And this vector have also 2 units from 1 to 3 and have also 4 units from 4 to 8. So they are equivalent. Both they have 2 units horizontally, 4 units vertically. For V and for U is 2 units horizontally and 4 units vertically. If you move it in space, and you have, if you move it in space, it will be equivalent. Let's go to move it. Let's go to see if I can move it. Let me see. Oh no, I cannot move it. Okay. But if you move it in this direction, the vector u, if you move it in this direction, you can move it up, it will be equivalent, any vector. So the question here now is how to obtain u. U is obtained by this theorem. Wherever you have a vector u, that is here, u is the vector u, that goes from 3, 2, and 5, 6. Okay, how I will obtain this vector? This vector, the tail is at 3, 2, and the head is at 5, 6. So this is the vector u. How I will obtain this vector? This vector is made of the difference of 2 vectors. This is the origin. So I will look for the vector that goes from the origin to the tail. I will look for the vector that goes from the origin to the head, and I will subtract. So this is the point P, and this is the point Q. So I will look for the vector OQ, I will look for the vector OP, and I will subtract OQ minus OP, and this is the vector U. Let's go to do it. Who is OQ? OQ is the vector that goes from O to Q. So it's 5I, you move 5 times in the x direction, 1, 2, 3, 4, and 5. And later on, you move 6 units going in the j direction. 1, 2, 3, 4, 5, 6j. So this is a vector OQ. What is the vector OP? The vector OP is the vector that goes from here to the point P. The point P is 3, 2. So the vector OP is 3I plus 2j. And what is the vector OQ minus OP? Is U, is the difference. Let's go to do the difference. The difference will be 5 minus 3 U will be 5 minus 3 in the I direction plus 6 minus 2 in the j direction. Or the vector u will be 2I plus 3 plus 4j. If we do the same thing for v, for the vector v, we will find that the vector v is made of 2I plus 4j. So they are equivalent because they have the same components. As a result, we learn that two vectors are equivalent when they have the same component. So what we have done is find the vector u. We found the vector u. Find, and we see that the vector is 2, 4. Find the vector v. We found the vector v. And we realize that they have the same components, 2, 4. So they are equivalent. Of course, that we can find the vector v. How we will find the vector v? Let's say that this is the point q prime, and this is the point p prime. The vector v goes from p prime to q prime. How we will obtain v? V is OQ prime minus OP prime. Is exactly the same thing that here is OQ minus OP is this vector, the vector that goes from P to Q. So if we find OQ prime is from the origin to Q prime is the vector 3I plus 8j. 3I plus 8j is OQ prime. And OP prime is 1I, P prime is here, is 1I plus 4j. If you make the subtraction, you will find 2I plus 4j. So U and V have the same components, so they are equivalent. Now let's go to solve a very similar problem. The vector U has an initial point 0, 3. You can represent the vector U whose tail is 0, 3, so it's somewhere here, 0, 3. And the head is 6 minus 2. 1, 2, 3, 4, 5, 6, and minus 2. So it will go to 6 minus 2. 1, 2, 3, 4, 5, 6, minus 2. It will go somewhere here. Somewhere here it will be. So the vector will be this vector. From the head, from the tail to the head. And the other vector is some vector that have the same magnitude and the same direction. How we will do the problem? First step, find u. This is u. This is the vector u. And we have to find u. To find u, we subtract components of p and q. So 6 minus 0, comma, minus 2 minus 3. And the u is 6 minus 5. So the vector u is made of 6 units in the x direction, 1, 2, 3, 4, 5, and 6. And it's made of 5 units in the minus j direction. That's why it's written minus 5. 1, 2, 3, 4, and 5. So this is the vector u. Next step, we find v. If v have the same components, 6 minus 5, it means that have the same direction and the same magnitude. By Pythagoras' theorem, the magnitude of this vector is 6 squared plus 5 squared. So to find v, we do the same approach that we did. B will be 9 minus 3, the head minus the tail, the x component, comma, the y components of the head minus the y components of the tail. And it will be 9 minus 3, comma, 5 minus 10. 9 minus 3 is 6. 5 minus 10 is minus 5. So they have the same components. 6 for the u, 6 for v. Minus 5 for u and minus 5 for v. So they are equivalent. Now let's go to do problem 3. Problem 3 say the vector u, this is the vector u, is 1. It goes from 2, 0 to 0 to 5, 5. Who is the vector u? The vector u, write the vector in components form. The vector u is made of 1, 2, 3i and 1, 2, 3, 4, 5j. The vector u should be, looking at the picture, should be 3i plus 5j. How I will find the vector u in another way? Well, this is P and this is Q. Who is OP? OP is the vector 2i, is the vector 1i, 2i. OQ is the vector that goes from the origin to Q, is the vector 1, 2, 3, 4, 5i, 1, 2, 3, 4, 5j, 5, 5, is the vector 5i plus 5j. And who is the vector OQ minus OP? Is the vector u. If you subtract, it will be 5i minus 2i, 3i, 3i. 5j minus 0j, 5j. And the problem is solved and we obtain the same result. Let's go to the next problem. Let's go to do the next problem. The next problem says the vector u has an initial point 0, minus 4. What is the point P? 0, minus 4 is here. And what is the terminal point is minus 5, minus 1. What is the point minus 5, minus 1, minus 1, minus 2, minus 3, minus 4, minus 5, minus 1. This is the point P, Q, the point Q. And the vector that goes from P to Q is the vector, is this vector. And now it says find this vector, find u. We call it this vector u. I can tell you that this vector is made of two vectors. It's made of this vector going up, that is, I'm going to tell you, is 1, 2, 3. 1, 2, 3 going up is 3j, is this vector, is 3j plus 5 minus I. So the vector u, without doing any calculation, the vector u is the vector 1, 2, I said, let me see, 1 to 3i, the vector u is the vector 3j going up, minus 5i. The vector I is this one. Minus I is this one. If you walk 5 meters in the direction of minus I, you go here. So 3j, this vector, 3j. Let's go to put it here, 3j. And now, minus 5i will be u. So I find u. 3j minus 5i, if you want to put it like this, 5i plus 3j. This is the visual way of doing the problem. The other way of doing the problem is as follows. Find OQ. OQ is the vector that goes from O to Q, and the vector that goes from O to Q is the vector minus 5i, 1i, 2i, 3i, 4i, minus 5i in the negative direction, minus 1j, 1 units in the minus j direction. The j direction is this one, and the minus j direction is this one. Okay, so this is OQ. Who is OP? OP is the vector that goes from O to P. So you move straight downwards. So you move 4 units, 0i in the x direction. You don't move to the right, you don't move to the left. You move downwards 4j, 4 times j in the negative direction. Minus 4j is OP. And who is U? U is the vector OQ minus OP. Who is OQ is minus 5i minus 1j. Who is OP? Minus, this minus. OP is minus 4j, minus 4j, minus is plus, is 4j, minus 1j, is 3j, so is minus 5i, minus 5i, plus 3j. So I have the same result. Which method is easier to do it? I believe the first method, but the first method is visual, and you don't make mistake. Let's go to the next problem. This next problem says we have the vector u, 4i plus 9j. 4 in the positive x direction, 4 units in the positive x direction, and 9 units going up in the positive y direction. So the vector u is this vector. Is the vector 1i, 2i, 3i, 4i, and now 9j. 1j, 2j, 3j, 4j, 5j, 9j. So the vector 9j. Okay, 9 times j plus 3 plus 4 times I. Okay, this is the vector u. This is the vector u. Okay. And it says, what is the magnitude? The magnitude of the vector u is the length of the vector. We can put the magnitude with double bar. This is better, because if we leave it like u, the magnitude of the vector u, you may think about the absolute value. But indeed, if you write it like this, the magnitude of u with only one bar is clear that u is a vector because I put it an arrow. Now how I will find? Well, Pythagoras' theorem will say that the magnitude of u is the square root of 4 squared plus 9 squared. So I found the magnitude of u, 4 squared plus 9 squared. You do the calculation and it will be a square root of 16 plus 81. 9 by 9, 81, whatever. So the second question say, we found the magnitude of u. It says, what is 2/3 of u? So you take the vector u and you divide in 3 times. So the vector u is not a unitary vector. It's a vector that has the magnitude square root of 81 plus 16. The vector u, if you divide the length of the vector in three equal parts, every part will be 1/3, another, let's go to put it 1/3, another 1/3, this will be 1/3 of u, and the last part will be 1/3 of u. So the vector u is made of 3 vectors, 1, 2, and 3. Every one will be 1/3 of u, 1/3 of u, and 1/3 of u. And the sum of the 3 vectors will be u. Okay, and the question is, who is 2/3? Well, 2/3 is from here to here. How we will find this vector? The vector that goes from here to here, 2/3 of u. The vector 2/3 of u is obtained by having u is 2i, u is 2i, u is 4i plus 9j, and 2/3 of the vector u is 2/3 of the vector u, 4I plus 9j. And how much is 2/3 of the vector u? Is 8/3 of I plus 9 by 2 is 18/3 of j. So this is the vector 2/3 of u. This is the vector that goes from here to here. This is 2/3 of u. 2/3 of u is 8/3 of I plus 18/3 of u of j. Okay, and there is more question. It says if b is 2 minus 5, who is v minus u? So if b is 2 minus 5, if b is 2 minus 5, v is 2 minus 5, 2 comma minus 5, it refers that v is 2i minus 5j. And u, the vector u, was the vector 4, 9, 4, 9, 4, comma 9. So it's the vector 4i plus 9j. And the vector v minus u is the vector v minus u, 2 minus 4 minus 2, minus 2i, b, v minus u, minus 5j, minus 9, minus 14j, minus 14j. So the vector v minus u is this vector. And is the vector that goes from the head of u to the head of b. Wow. And the last part, it say, who is 5u, 5 times the vector u, minus 3 times the vector v. This is 5 times the vector u. The vector u is the vector for I plus 9j. Minus 3 times the vector v. Who is the vector v? The vector v is 2i minus 5j. So this would be 20i plus 45j minus 3 by 2, 6i minus 3 by multiply by minus 5 plus 15j. So we sum 20 minus 16 minus 6 is 14i, and 45 plus is 16j. And this is the vector 5u minus 3v. 5u minus 3v, and the problem is done. Okay, this is the result. Now we are going to solve this problem. It says let u to be minus 3, 4, and v to be 3,0. What is the magnitude of u? The magnitude of u is Pythagoras theorem, is the component square root. So if you make the calculation, you will find that the magnitude of u is 5. Is minus 3 squared plus 4 squared square root, which is square root of 25, which is 5. The second question says, what is minus 3u? Take u and multiply by minus 3. If you take u and you multiply by minus 3, you will find minus 3 by the vector u, minus 3, 4. 3 by 3, 9, minus by minus produce positive 9. Minus 3 by 4, minus 12. So the vector minus 3 times u is the vector 9, minus 12. You can represent the vector u, and you can see how represent the vector minus 3u. The vector u goes in one direction, the vector minus u go in the opposite direction, and the vector minus 3u is adding minus u 3 times. The third question says, who is v minus u? Okay, we know who is v. V is 3,0. who is v minus u? We know who is u. U is 3,4. So v minus u is 3,0 minus 3,4. 3 minus minus 3 is 6. And 0 minus 4 is minus 4. So the vector v minus u is 6 minus 4. And the third question say who is 6u minus v. So you can do it again. You find first 6u and you subtract the vector v. 6 times u is 6 times the vector u. The vector u is 3 minus 3, 4. 6 times minus 3 is minus 18, 24, minus 3,0, minus 24 minus 3, minus 18, minus 18 minus 3 is minus 21. And 6 by 4 is 24, minus 0 is 24, so the vector 6u minus v is minus 21,24. It's worth it that you do it geometrically. Geometrically speaking, it's good to see the geometry, how it works. This vector say find the unit vector in the direction of A, of the vector A. The vector A is the vector 5,12. So it's the vector 5i plus 12j. And this vector have a magnitude. The vector A have the magnitude square root of 5 squared plus 12 squared. And 5 squared is 25, and 12 squared is 144, and the square root of this is 144, 160, 469, 169, which is 13. So the magnitude of A is 13, and the vector A is 5 minus 12. So how we are going to find the unit vector? The unitary vector means that this is the vector A, and we need to find a vector in the direction of A that have the magnitude 1. So this is the vector. Unitary vector in the direction of A. Well, the idea is to see this equation. The vector A is made by the magnitude of A in the direction of u sub A. What it means this? It means that the magnitude of A is 13. If you put 13 times u sub A here, 1, 2, 3, 4, 5, 6, 7, 13 times, you reconstruct the vector A. So A is the vector A is the magnitude of A multiplied by u sub A. So this will say that the vector u sub A, the unitary vector in the direction of A, this vector, this vector u sub A that have the magnitude 1, u sub A is the vector A divided by the magnitude of A. Oh, but I know how is the vector A. Is 5i plus 12j. And I know what is the magnitude of A. It's the square root of 13. So who is the vector u sub A? The vector u sub A is 5 divided by square root of 13. Sorry, not by square root of 13. 5 divided by 13. Let me erase because the magnitude of the vector is 13. So it's 5 divided by 13 in the I direction plus 12 divided by 13 in the J direction. And if you think that you are not sure that if this is a unitary vector, we can find the magnitude of this vector. The magnitude of u sub A should be 1. So it should be, the magnitude of u sub A should be 1. The magnitude of u sub A should be 1 because we have found a unitary vector. And what is the magnitude of this vector? is 5 divided by 13 squared plus 12 divided by 13 squared. Wow, is this 1? Let's go to calculate if this is 1. Okay, let's go to calculate. The magnitude of u sub a will be a square root of 5 divided by 13 squared plus 12 divided by 13 squared. Should be 1. Let's go to check it. It should be 25 divided by 13 squared plus 12 squared, which is 144, divided by 13 squared. So this should be a square root 165 divided by 13 squared. But 165 is 13 squared. Divided by 13 squared, this is 1. So, as I promised, this vector is the unitary vector in the direction of A, in the direction of the vector. It's very important to know how to find the unitary vector in the direction of A, and the equation that you always will be applying is this equation. U sub A is the vector A divided by the magnitude of A. Okay. Next problem, say find the vector V that has magnitude 2 and makes an angle of 150 degrees with the positive x direction. So who is the vector? The vector is this one. Let's go to localize the vector. Sorry. Let me put it well. Let me localize the vector. The vector have the magnitude 2. So this vector have the magnitude 2. This is the magnitude, is 2 units. And the angle is 150 with the positive x direction. Who is the vector? The vector, let's go to call it V. The vector V have a very simple, standard, and always the same representation. A vector V can be written in this way. The magnitude of V, cosine of the angle alpha, this angle 150, plus the magnitude of V in the I direction, plus the magnitude of V sine of alpha in the J direction. Always the vector V can be written in this way. The magnitude of V cosine of alpha I plus the magnitude of V sine of alpha J, with the detail that alpha have to be the angle that makes with the positive x direction counterclockwise. Always should be counterclockwise. So in this case, the vector V is the vector. The magnitude V, 2, cosine of 150 I plus the magnitude V, 2 sine of 150 J. And this is the vector V. And now, cosine of 150 is negative, so this number is negative. Because to make this vector, you need to move in this direction negative. And you need to move up positive in the J direction. So sine of 150 is positive. So this is the result, and if you want to use your calculator, V will be minus 2 times cosine of 150. Cosine of 150 is a square root of 2 times 150 will be a square root of 3i plus 2 times sine of 150. Sine of 150 is the same that sine of 30. Sine of 30 is 1/2. So 2 by 1/2 is 1. So plus 1j. So if you use your calculator, you have this expression for the vector b. It's a walk minus the square root of 3 in the minus I direction. Walk a square root of 3 in the minus I direction, and later on walk 1 meter in the j direction. And the magnitude of this vector, if you use Pythagoras theorem, is 2. Do it. Calculate, and you will see that it's 2. And the angle with the x-axis is 150. This is problem 9, and it says there are two forces acting on an object. This is one force. It exists under the angle 10 degree counterclockwise through the positive x-axis, and the other one exists on the angle minus 10 degree. So we will use this angle, the angle through the positive axis x counterclockwise, so the angle will be 350. So we have two forces, F1 and F2. Both of them, they have the same magnitude, 400. Who is F1? F1 is the force 400. I said that a vector A can be expressed like the magnitude of A cosine of alpha in the I direction plus the magnitude of A cosine of alpha sine of alpha in the j direction. This is what I have said in the previous problem. So F1 is 400 cosine of 10 in the I direction plus 400 sine of 10 in the j direction. This is the vector that represents F1. So F1 is made of two vectors. This vector, let's go to put it in another color, this vector plus this vector. Oh, in the opposite direction, going up, plus this vector. This part is 400 cosine of 10. This is the magnitude 400 cosine of 10. And this one is 400 sine of 10. Who is F2? Well, F2 is the same thing. Is 400 cosine of what? Cosine of 350 I plus 400 sine of 350, 10 degrees less than 360 is 350J. Okay, and what is F2? F2 can be written like this, 400 cosine of minus 10, because cosine of minus 10 is the same of cosine of 350, plus 400, multiplied by the sine of minus 10 in the j direction. So F2 can be written like 400. Now, cosine of minus 10 and cosine of 10 is the same thing. And now, sine of minus 10 is minus sine of 10, minus 400 sine of 10 in the j direction. So now I have to make the sum of this plus this. If I do it geometrically speaking, the sum will be F1 plus F2 plus F2 will be this one, F2, this is F1 plus F2, so I will have this, the sum of F1 plus F2, this is F1, this is F2, so the sum will be here, right? The sum will be this one. So I expect that the sum of these two vectors will lie on the x direction. So let's go to sum it. 400 F1 plus F2. How do I sum? Component by component. So I will sum this component with this component. So I will have f1 plus f2. I will have 2 times 400 cosine of 10 in the I direction plus, now we will have to sum 400 sine of 10 with minus 400 sine of 10. This is 0. So the result of f1 plus f2 is 800 cosine of 10I. So this is the total force acting on the body. F total, F1 plus F2. And what is cosine of 10? Well, you go to the calculator and you multiply by 800, and it will have this length. Okay. Okay, the length of the sum will be this length. Okay. And I think there is one more problem. This is the last problem. Find a unit vector parallel to the graph of fx equal x cubed at the point 1, 1. It's not so easy to understand what it says, but let's go to clarify what it says. It says you have the graph of x cubed. This is the graph of x cubed. X cubed will do like this, and will do like this. This is x cubed. And at the point 1, 1, at this point there is a slope. What is the slope? The slope f prime of x of the curve of the function x cubed is 3x squared. And the slope at the point x equal 1 is 3. So this slope, the slope here is 3. When you have a slope 3, it's because you have 3 units up and 1 unit in the horizontal direction. So the slope of this point is 3, meaning that 3 divided by 1 is 3. This is a slope. A slope is delta y divided by delta x. Delta y divided by delta x. Okay. So I can imagine here that there is a vector, this vector. But this vector doesn't have a unit, is not a unit vector. Who is this vector? This vector is the vector, let's go to call it A. The vector A is 1i plus 3j. But this vector is not a unitary vector. How we will find a vector that is unitary in the direction of A? So this is the vector A is 1i plus 3j. What is the unitary vector? Is the vector A divided by the magnitude of A. How I will find the vector u sub A, the vector unitary in the direction of A is 1i plus 3j divided by the magnitude of A. The magnitude of A is 3 squared plus 1 squared. So it's 1 divided by 10i plus 3 divided by 10j. So the vector that he's asking me is this vector. Okay, good luck.